I decided this room was more fun than the other room, so I wanted to move. I'm presenting Alexandra's slides. She's the EPO lead for our Science and Exploration Potential at the Lunar Poles NLSI team. Our proposal often use the term unknown moon in it, and I realized last night going through these slides that we probably need to change that now. You can't really have spent yesterday here looking at all those talks and think that the moon is that unknown anymore. We chose the poles at the time because they were the targets of NASA's new generation of explorers, and many of us still feel that when we go back with people it will be going back to the polar regions. Our team uses a large mixture of both scientists and engineers to look at a number of different aspects of the poles, using data from both past, current, and I didn't do that. I obviously did. Okay. The study areas for the team and the EPO effort is very much linked to the work being done by the team. All the scientists and engineers realize that EPO is a very important part of what we do. So the three sort of themes for the research is there's the lunar polar environment, where what are the poles like? So we're looking at remapping the polar geology with the new data sets, looking at the illumination conditions, the very unique illumination conditions where you get places near the poles that are almost constantly illuminated and many which never see the sun. Also looking at how volatiles would exist near the poles, how they would move around, where they would likely to be and what form they would be in. We're also looking at surface characterization, and that's very much looking at slopes and rock distributions and as phrased here, part of that is thinking about where are the safest places to land. Quite often the poles are thought of as very different than the equatorial regions, and that really isn't the case. Often they look different because of the low sun angles, but the surface isn't that different. And finally, we're looking at surface science, instrumentation, and operation. So this is once you're actually back on the surface with either people or robotics, what would you do? And we have people thinking about how hard is it to excavate and to have mobility, to have, say, rovers on the moon. We have a number of different science instruments for doing science on the moon, as well as science from the moon. We have people looking at how would you study the Earth with a small telescope from the poles, such that you would determine that the Earth has life. What are the actual signatures of life? And once you can determine that, you can use that information to help you design telescopes to look at extrasolar planets and see if they have life. One example being you can use the polarization of the glint of the oceans, for example. Don't you love it when you do slide mode of slides you didn't make? Okay. I should have done it in slide mode last night. Oh, okay. So this summarizes the activities. We have APL internships, the Higher Education NLSI lecture series, the Unknown Moon Institute that I'll spend quite a bit of time. This is probably our turnkey, most important, our largest scale operation. Space Academy for middle school students. We have a website about to go live, and we have a fact sheet, which I wanted to check if you have copies. So we have two summer interns this year who are doing an excellent job. Natalie Glines is a junior from Mount Holyoke, and we have her using MiniRef radar data to study the poles and look for interesting craters all around the moon. We also have Austin Green, who's also a junior from University of Maryland, who's helping me with my polar illumination studies. They've both done an excellent job. They've learned new skills since we've really stretched them, and they feel they've learned new skills since they've arrived. We very much hope that their work will lead to LPISC abstracts. And one of the things I like to do is if you have interns who work hard and do a good job, I do like to try and take them to the Lunar and Planetary Science Conference and let them present their work. And I think that gives them, coming to conferences at that stage of your, early stage in your career, really can be quite an exciting prospect. It's only when you get old and jaded that the conferences aren't fun. We have the NLSI lecture series, and different science team members from our team go to different educational establishments in the Maryland area and give seminars. And the hour-long seminars, we make sure we allow a lot of time for questions and answers. These are stored as video, which is for later watching on the internet, which is quite scary when you're giving the presentation. You know that you're being recorded. We also make sure that as part of these talks, we discuss with the professors and teachers that are there of what are the undergraduate and graduate student opportunities for coming to interact with the team longer term. We explain about different intern programs, not just at APL, but also sort of NASA intern programs. So our formal education program are high school teacher workshops. We refer to this, as I said, it's our cornerstone activity. We refer to this as the Unknown Moon Institute. It's a week-long immersion focusing on lunar science and the processes at the poles. We hold these every summer, and they alternate between the Applied Physics Lab in Laurel, Maryland, and the Lunar and Planetary Institute in Houston, Texas. We found that having this sort of one-week immersion it generates a lot greater depth of knowledge for the educators who are visiting than just having a one-day workshop. We had a good workshop last year in Houston, and the one for this year actually starts next week. So the goal is to build content and teaching competency for high school science teachers to help them engage students with STEM content. The content aligns with the National Science Education Standards. The high school educators, particularly those serving Hispanic students in the LPI region and the African American students in the APL region, are encouraged to attend. Recruitment is in conjunction with the Maryland Texas State Science Teachers Association. So a quick summary of the workshop content for this year. I mentioned it's a 5-day full-on. So they spend day one, studying the moon, examining the moon at scale, cratering landforms, learning a lot about the moon. Day two, we delve more into lunar geology, talk about how the moon formed and it evolved. Day three, we start to concentrate on the lunar poles, which is the focus of the NLSI team, and talk about volatiles. Then day four, we talk about lunar exploration, both future current and also future exploration. And then day five is collaborative activities and wrap up. So in addition to this, we provide hour-long. They receive a couple of hour-long lectures. One typically from, well, in this case, me next week. One from somebody local, but last year, for example, I also gave a lecture via VideoCon to the teachers down in Houston. We're going to try and repeat that in the other direction next week. The Space Academy was created by the APL EPO office and is co-sponsored by Comcast Cable, Discovery Networks, and APL, because obviously we're telling children, watch TV. No. So it gives middle school students a close-up look at NASA missions. Students study the mission of space-related careers through classroom activities and videos. One of the exciting things is we held a mock NASA press conference where we present results from either an ongoing mission. We have engineers and scientists and program managers. We even have some people from NASA headquarters have come up to that. And so it looks just like a NASA press conference, and then we get them to ask questions. And I've been amazed the times we've done this is we've got like an hour schedule, and we only have about 30 to 40 minutes for talks, and I see this 20 to 30 minutes for questions, and I'm thinking, well, what are we going to do for the final 15 minutes? And they just ask questions until the time is up. What we do is that they are screened in that it's seen as a reward in their local schools. So the students that attend have gone to some effort to be able to attend. They're also asked to come with a question prepared, which really gets them thinking about what they're going to see, and probably contributes to the fact we get so many excellent questions during this. Some photos. So there we have an example of the mock press conference. They get to go to the clean room at APL. This is me telling them I used to be a scientist, but now I'm a manager, and he's looking disappointed. This is where we electrocute the students if they ask a question that we don't like. Our team's webpage is going to go live probably within the next couple of weeks, and we're very excited by that, and we're very keen to keep adding to content and representing the latest results that the teams produce. Finally, our NLSI fact sheet won a gold medal in the Communicator Awards. We were very excited by that. That was very pleasing. And hopefully it got it not just because it was round and unusual. Finally, one of the things we're producing also is a tool. I'm also PI of Mini-RF, which is a radar instrument around the moon. And we have taken the tool that the scientists use to access the data and are producing a version of that for the general public, which will go live hopefully within the next about 6 weeks. And that will be able to allow the public to access the data very easily using sort of a Google Maps 2D interface. And the best thing about giving talks to someone else is if you have any questions, here's the email. But I will do my best. Thank you.
Thank you, Ben.